Today is day 463 of data science, and I'm here in Jupyter Notebook because I can't actually use this library Handcalcs in Google Colab. So I'm here, and I'm just going to first start by importing Handcalcs, right? And then click on a new cell, and then I'll do import handcalcs.render. All right, so here's what this is going to be. Um, Back in high school, I basically used Python to answer my homework questions, and I would always find kind of like, I would make these functions to calculate like the p-value for my stats class and whatever, but I would only get the answer, and I was like looking for a way to like show the work. I think it was day 216 where I was like looking for something like that. Yeah, 216. Today I researched how to print expressions using Python and I stumbled upon this library called SymPy, but some of its functions are outdated and all I really want is a division sign. And I just could not find anything other than that. And I even like looked at it earlier this week and I was like, oh yeah, and I was like still it's kind of a but I discovered Handcalcs, which is actually working for me. So it's basically the same thing. It kind of just outputs your work like mathematically. So I thought that I would take a very simple equation like the z-score equation and try to output that, see if I could do that. I did it the other day with some like the quadratic formula, I think is what I did, but let's see if I could do it with this. So first things first is setting up variables. So I'll do like z, or actually let me do x mu, I'm gonna say u, and then o, I'm gonna say for sigma. And I guess I'll put up the z over here. And I'll just do like z is equal, well, let me not do z because that's not a value yet. I'll do, let's say, I don't know, 20, the mean would be 5, or maybe the mean would be 25, and then the standard deviation would be 4. And then to actually get these variables printed, I would actually have to use this thing called the magic key or a magic cell, actually. So to get magic cells, you do 2% signs, and then for us, it's render. So what that does, it just allows you to basically use, um, to kind of use a certain language. I know that if I do like HTML, for example, let me actually do that. So if I do HTML, I'm basically allowed to like render HTML out now. So if I do like an H1 say hello world and then run that, I'm going to get hello world as an HTML, which is amazing, right? So I'm not sure how render is because I'm not sure if it's like a language or something. Um, but it's the same idea. I'm allowed to use this, right, to render out the variables. And it's called a magic cell. So let me go and delete this. So now if I run that, I get my variables, right? Written symbolically, which is pretty awesome. Versus, I mean, there wouldn't be a way to do it. I would have had to do like print and then x and then equal, I would say x equal and then plus and then the value of x as a string. I mean, that would have been the way to do it, right? With regular Python. But this one just does it for you if you just do render, which is pretty amazing. So then if I want to do the equation, I can do z is equal to x minus u, and then I would put them in parentheses, and then divide by o. So if I run that, I'll be able to see the actual equation, which is amazing. And it puts in the numbers and it shows you the work, which is exactly what I wanted like 200 days ago, like 216. We're in like 463. But yeah, it's absolutely amazing. Exactly what I was looking for. And then there's a little bit of I can't even speak, customization or something. So you can do like render short, and I believe that's by default, but it takes your equation and it renders it in like the same line. But if you do render long, I believe it uses multiple lines. So you see like z is equal to blah blah blah. This only apparently works for the equations and not the variables. Let me see if I were to just do another cell and then put in render and put the equation here, run that. Right, so it knows that it's using these variables. Okay. And let me run this. All right. And if I do short, it should put it in the same line or not. What if I do params? Beautiful. Okay, so apparently, let me try params long. There we go. All right, so apparently I have to target the params, which are basically parameters. You can think of them as the variables themselves. So it's saying, okay, render the parameters long form, so vertically. And if you want them in the same line, then you would do short. Or I think that's by default. By default, it's short. All right. So render params just renders your variables basically in the same line. And if you want them to be long form, so vertically, you would do long. All right, beautiful. Okay, so I think that's that. And then when you want to render the equation, you can just do render and then get put the equation, and then it just shows you, it puts the equation symbolically, and then it plugs in the numbers, which is absolutely amazing, and then it gives you the answer, right? And again, you have the option to do long, which is vertically, right? So it kind of uses that vertical space, and then you have the option to do short, which um, that's what it is, and by default, I believe it's short, right? Because if I run that, it's still the same. All right. And then I guess the other thing would be to just render the equation symbolically. Um, so I would do, let's do render, and then I'll put in the same equation, and if I remember correctly, I think it's something, I don't know if it's like this. Oh yeah, okay, so it's symbolic, that's the keyword. So if you put symbolic, it would only render the equation symbolically, which is, again, absolutely amazing because I remember just like being so frustrated because I couldn't find anything like this. Um, and I'm just so happy that I did find something like this and it just works so nicely. So yeah, so that's kind of the idea. So you can render out the equation symbolically. I think what I'll do is actually be more accurate and get the mu symbol if I could find it. So let me go and replace those so that everything is just how it is. And then I'll do the same thing for the sigma symbol in stats. Whoops. So I guess from now on, I think I'm gonna spend a few days going back to like you know, my days 200 to 300 because I have a lot of functions that I wrote for my stat class that helped me, with my homework and stuff just to kind of check my answers. And I guess I'll just go through them and then just edit them so that I can actually see the work, not only the answer, but the work also and the formula also. I mean, I think that would just be amazing. And very, very efficient. Let's see, I'm gonna paste that in here. Now, this doesn't actually work with Google Collaboratory, which kind of is really sad because I think Google Collaboratory actually has its own like specific keys that it brings that it allows, and this is not one of them. Now, when I put the sigma, for some reason it's not letting me, let's see, it's not actually rendering out the thing. Is it because, well, it is sigma over here. Well, yeah, that's kind of what I wanted to figure out, if it was affected by symbols like that are not letters. That's interesting. So it takes in mu, but it doesn't take in sigma, or maybe it's just something that I'm doing wrong. If I render this and then I render that. Interesting. What if I do O? Well, that's weird. Okay, so it turns out that maybe it's just me, but for what I know now, it's not letting me render with at least the formula with, the symbols like with mu and sigma. So I guess I would have to look for special symbols. Maybe Handcalcs has like a list of those that I can use. I know that I think SymPy um, has maybe some of them, and I can use SymPy with Handcalcs. So maybe I'll go and do some research with that. But I guess we'll just go and put these back to how they were. So this was O, and this was U. I think I'll leave these the way they are because these do work. These do work as well. So maybe it's just me. Maybe I'm doing something wrong. But I'll render these also with their normal letters. So U, and then O, and then I'll take this one also. Let me bring this one down over here. Take a plus sign and paste that in there. And it changes this to U, and then O. Let me run these. Because I put a 0 in there instead. Right, beautiful. So now it works. Little experimentation here because I didn't know if it was going to work or not. And then for this one, I'll leave this with you. And then obviously this doesn't work here. I just want to show that it doesn't work. And this, I want to put this up here to see kind of the alternative of how to get these. Where's the code here? All right, and if I do like mu and then sigma, run that, it only gives me z, right? So it's interesting. I'll actually bring this one down, right? And then I would put one after here, but with u and o. Right, so that doesn't work. All right, so the bottom 44 to 47, those are the ones that work with like without like certain symbols. The letters work perfectly fine. Even with the symbol, it works up until you have to, render it out symbolically, then it doesn't work. But yeah, that's a little experimentation or result for today, I guess. So yeah, that's it for today. Bye.